Hello friends, you are watching Data Structures using C. All the videos are brought to you by Ankpro Training from Ankpro Technologies. Hello friends, in the last class we have introduced the graph data structure and we have seen how we can draw the graph, what are the elements involved in the graph and everything. And today in this class I'm going to show you how we can represent the graph data structure in the memory and what is the code that can be used to design the graph data structure using C program, right? So let's recall the definition of graph. A graph is a non-linear data structure, which means elements are not stored in the linear order, and which graph contains a set of points known as nodes or vertices and set of links known as edges which connect the vertices, right? So there are two kinds of representation of graph. We can use the adjacency matrix to represent the graph in the data structure, and we can also use the adjacency list to represent the graph in the data structure. In this class, I'm going to show you how we can represent the graph using adjacency matrix. For that, we are going to use the two-dimensional array which represents the matrix, and using that two-dimensional array, we're going to represent the graph in the adjacency in the form of adjacency matrix, right? So first let's understand what is adjacency matrix. Let us consider this graph which has got 4 nodes A, B, C, D and 5 edges, right? So the number of vertices is equal to 4 and the number of edges is equal to 5. So this is the adjacency matrix for this graph. A, B, C, D are the names given to the nodes, and we're going to fill this matrix with ones and zeros, right? We're going to map from one node to node. If there is a connection between one node to another node, we will represent that connection as 1. If there is no connection between a pair of nodes, and we will represent that with 0, right? So how we'll map connection from A to A to B, A to C and A to D. Connection means the edges between the nodes, and the edge between B to A, B to B, B to C and B to D and so on. So let us start from the node A. So from A to A, is there a connection from A to A? There is no edge between a node to itself, right? So this will be represented as 0. What about A to B? So there is a edge A to B, so this will be represented with 1, right? So because there is a connection from A to B, I'll put 1 in the cell A to B. So there is also connection from A to C, so let us put 1 in A to C. And there is a connection between A to D, so 1 in A to D. Now come to the B vertex. From B vertex to A, there is a connection, so that it is represented as 1. B to B, there is no connection or there is no edge from B to itself, so it is 0. And B to C, as there is, so it is 1. And B to D, no, there is no direct connection. So here the connection or edge means the direct connection, because there is no edge from B to D directly, so it is represented as 0. Next, with the vertex C, C to A, as there is a connection, so it is 1. C to B, it is 1. And C to C, no, so it is 0. C to D, it is, so it is 1. Now with the vertex D, so D to A, as it is, so it is 1. D to B, no direct connection between B and D, so it is 0. What about D to C, as it is, so D to D, no. So this is the adjacency matrix for this graph, right? So this is how we can represent a graph in the memory of data structure. So using this, we are going to, so with the help of this adjacency matrix, we are going to build a two-dimensional array which represents this matrix. And first we will assign zeros to all the memory locations. Then we'll ask the user to enter the pair of nodes like A to A or B to C or C and B, like this. if the user enters the pair of nodes, and we will match these pair of nodes and we will put 1 in the cell which is the pair of 2 nodes, right? So we're going to do that. First, I'm using the structure to represent the graph. So using the struct keyword, the structure name is graph. Here I've declared 3 variables. One is v, which stores the total number of vertices, and e, which stores the total number of edges among the vertices, and the adjacency pointer. So this pointer points to the adjacency matrix, right? So once this is executed, I will get this node, this graph structure. So we will hold the number of vertices, right? And he will hold the number of edges among the vertices. And this adj, this is a pointer, the double pointer you can call. This means the pointer to the pointer. So if I go and build a two-dimensional array like this, so to how to access each and individual cells in this matrix, with the help of adjacency pointer, I'm going to point to each and individual cell. So that is why I've declared this as a double pointer. So this will point to the array. If you want to point to any cell in the two-dimensional array, that must be the double pointer. Okay, so here is the code. I'm using the adjacency matrix of graph function. This is the function name, and this is going to return the address of the structure graph, right? Let's do that. So I've declared 3 variables here, u, v, and I. And using the malloc function, first I will allocate the memory for the node which I just explained. So the type of address that is going to return is struct graph, right? This will allocate the memory required for one structure of graph, right? So this will allocate using the malloc function, and it will return the pointer of the type struct graph, right? And that will be stored in G. So G is a pointer which stores the address of this structure. So now G is pointing to this structure, right? So this has been allocated. So the memory required for this structure, because this is going to hold the total number of vertices, total number of edges, and the pointer to the adjacency matrix, right? If G, that means if G is null, right? If G is null, I'll tell no memory allocated because of some issues. If this program unable to take the memory, I'll tell no memory allocated, and I'll return from this function. No further statements will be executed. Otherwise, I'll start with the further statements. So enter the number of edges. I'll ask the user to enter the number of nodes and edges. So he will enter using the scanf functions, and I will store the nodes in g arrow v. That means here, say suppose he entered 4 number of vertices and 4 number of edges. So that will be stored in g arrow e, right? So okay, user has entered 4 edges and 4 vertices. So now I'm going to create the two-dimensional array using the malloc function. So what is the size of the two-dimensional array? G arrow v multiplied with g arrow v. That means 4 cross 4 matrix of size int. So that is total number of 16 bytes, right? And this will, the address of this block will be stored in g arrow adjacency, that is this. So after this execution, I will get this, and the address of this matrix is stored here, because g arrow adjacency will get the address of this newly created block, right? That is array. Okay, I'll erase this. I hope you understood this. Please trace by yourself to get the clear idea. Right, so the address of this cell has now stored in this adjacency pointer, right? I hope you knew that how to initialize the two-dimensional array. If you don't know, please go and watch our C programming playlist where we have explained two-dimensional array and single-dimensional array and how to initialize it. And to do that, I'm using the two for loops. One I initialized u with 0 and v with 0. So u represents the total number of vertices and v represents total number of edges. So until u remains less than g arrow v, that is less than 4. Until v remains less than g arrow v, that is total number of edges only, because both are 4, so I'm using the same variable here, right? And I'm going to store add u arrow v. That means u arrow v, that is 0 comma 0. This is 0 1 2 and 3, and this is 0 1 2 and 3. So u comma v, what is u? U is 0, v is also 0. So u comma v means 0 comma 0. That means this cell, and I will store 0 inside this cell. So I'm going to repeat this loop, iterate through this loop, and I'll store zeros in all the cells. So this is what I get after executing this loop. So this is the output of this two for loops, right? And I'll tell the user to enter the node numbers in pair for an edge. That means the user has to enter either 0 0 or 0 1 0 2 0 3 to make a connection between those two nodes. Say suppose, and I am using the for loop there, right? Say suppose user has entered 0 1. So 0 is stored in u and 1 is stored in v. So I have to make this cell as 1. So to do that, I am using g arrow adjacency u comma v. That means this cell, right? This is on 0 comma 1. Now this is no longer be 0, this is 1 now, right? And v comma u also 1, because this is not a directed graph. If there is an edge between 0 and 1, there is also edge between 1 and 0. So v is 1, 0, u is 0. So I'll store 1 also in 1 comma 0. That is here. So I'll store 1 here also, right? And again this loop iterates, and the user has to enter the next pair. Wherever he enters, I'll store 1 inside the cell. So this will be repeated until he enters the 4 pairs of the nodes, right? Because there is 4 pairs, 1 2 3 and 4. I hope you understood this code. If you don't understand, please comment below. We will try to answer it. Well friends, that's it for the class. Subscribe to our channel on YouTube, like our page on Facebook, follow us on Twitter, and join our group on LinkedIn. Thank you.